video, we will tackle the fractionation.
What is fractionation? It is a separation process in which a certain quantity of a mixture, gas, solid, liquid, enzymes, suspension, or isotope is divided during a phase transition into a number of smaller quantities, a fraction in which the composition varies according to a gradient. Fractionation in the most general sense could mean any process whereby a mixture is separated into different components or fractions. Fractionation in this general sense, however, would include diverse methods and techniques that may have a little in common. Such methods and techniques may be broadly grouped in four classes, namely fractionation proper, general separation, analytical separation, and purification. It is important to note, however, that this is not an exclusive classifications, as some methods may have characteristics belonging to more than one of these classes.
The mixture to be separated could be a homogeneous mixture, such as a solution, or a heterogeneous mixture, such as a mixture of solid and liquid. The mixture to be separated may also be gaseous, liquid, or solid. The fractions are separated based on differences in a specific property on the individual components, such as boiling, freezing, or melting points. The phase changes involved could be a condensation for vapors and gases, boiling and evaporation, or freezing and crystallization for liquids, and melting or sublimation for solids. Most of these processes find application on industrial scales, but some processes such as fractionation by sublimation are restricted to a laboratory scale procedure.
Among the 5 fractional processes, I choose fractional distillation as an example of fractionation. Fractional distillation, where mixtures of liquids and gases are separated by difference in boiling point. These are the apparatus that will needed to perform the fractional distillation. Wire grows. The distilling flask or round bottom flask. Bunsen burner. Three-way adapter. Fractionating column with beads. The Liebig condenser. Thermometer. Receiving flask or Erlenmeyer flask. Torch stand clamp. Vacuum adapter.
You should assemble and know how to use the apparatus. Bunsen burners are generally used to rapidly heat high boiling liquids with low flammability, such as water. Safety note: it is important to know that they can reach temperatures of approximately 1500 degrees Celsius and can easily ignite most organic compounds. If an apparatus is improperly set up, or if there is a small gap that allows organic vapors to escape from an apparatus, these vapors can ignite with burner. A wire gauze set atop a retort stand clamp is often used under the flask to dissipate the heat and avoid overheating one area. The filtering flask or round bottom flask attached under the fractionating column. In a fractional distillation, a mixture of liquid is boiled and the resulting vapors travel up a glass tube called a fractionating column and separate. The fractionating column is placed between the flask containing the mixtures and the three-way adapter and improves the separation between the liquids being distilled. In the three-way adapter, upper part was holding a thermometer to determine the boiling temperature of the liquid. When water is allowed to flow into the condenser, it surrounds the inner tube and creates a cooling effect. That way, when the vapors from the boiling liquid hit the cool area of the Liebig condenser, they condense back to liquid form, which is how the condenser actually works. The other arm of adapter connects to a Liebig condenser into which cold water is constantly passed through the receiving flask or the Erlenmeyer flask for collecting the distilled liquid. To collect a multiple fraction, you can have another Liebig flask. When water is allowed to flow into the condenser, it surrounds the inner tube and creates a cooling effect. That way, when the vapors from the boiling liquid hit the cold area of the Liebig condenser, they condense back to liquid form, which is how the condenser actually works. In a fractional distillation, a mixture of liquids is boiled and the resulting vapors travel up a glass tube called fractionating column and separate. The fractionating column is placed between the flask containing the mixtures and the Y adapter and improves the separation between the liquids be distilled. In the process of fractional distillation, there are different equipment that we're gonna use in order to finish the process. So first equipment that we're gonna use is a sheet of thin metal that has net-like patterns. Wire gas is placed on the support ring is attached to the retort stand between the Bunsen burner and the glassware to support the beakers, flask, or other glassware being heating. Second is the filtering flask. The filtering flask or round bottom flask is attached to the fractionating column and to three-way adapter holding a thermometer to determine the boiling temperature of the liquid. The adapter connects to a condenser into which cold water is constantly passed through. Third equipment that we're gonna use is a Bunsen burner. A Bunsen burner is a kind of gas burner used as laboratory equipment. It produces a single open gas flame and is used for heating, sterilization, and combustion. Fourth, three-way adapter. A three-way distillating adapter, also called.
Understand more the separation of acetone and benzene by fractional distillation.
As the difference in boiling points of acetone were 329 Kelvin and benzene, whose boiling point is 353 Kelvin, is only 24 Kelvin. Their mixture can be separated by the process of fractional distillation using fractionating column. Let's see how could this be done. The mixture is taken in the distillation flask. Fractionating column is inserted between distillation flask and Liebig water condenser. The flask is heated on water bath. At a steady temperature of 329 Kelvin, acetone distills out and is collected as first fraction in the receiver. The vapors of benzene are cooled in the column and liquid benzene trickles down back into the flask. When acetone is distilled out completely, the temperature starts rising and the receiver is changed. When the temperature becomes steady at 353 Kelvin,
Benzene distills out and is collected as second fraction in the receiver. Acetone and benzene can be further purified by redistillation using simple distillation apparatus. All for today's video. Thank you for watching.